Alright guys, so now we're going to be talking about 1.6 notes. So these are piecewise defined functions. So let's start with defining what a piecewise defined function is. So it is a function defined by multiple functions and then it's defined, so a function defined by multiple functions on different intervals of the domain. And what that really is just trying to say, guys, is that a piecewise defined function is all these pieces and parts of different functions put together on different parts of the domain or in different x values. So then let's take a look at number one. Number one says given f of x is equal to that piecewise function. So this is what a piecewise function looks like. Find each value. So the first one says find f of -5. So that's telling us to plug in -5 into the equation. Well, then we need to decide which one do we plug it into. Do we plug it into the top or do we plug it into the bottom? Okay, that's where the domain comes in handy. So the domain is this part right here. It says we use the top equation when x is less than -2. Well, -5 is less than -2, so we're going to pick our top equation here. So -5 squared minus 1, that gives us 25 minus 1, which gives us 24. The next one says f of -2. So then we're going to use this bottom equation because the bottom equation is for when x is greater than or equal to. So because we're talking about the number -2, it's equal to -2. So 5 times -2 plus 3, it's going to give us -10 plus 3, and we get -7. And then the last one here says, well, what is f of 7? Well, 7 is going to be greater than or equal to -2, so we use the bottom equation again. So that's 5 times 7 plus 3, which is 35 plus 3, which is then 38. And that's how you would plug things in to a piecewise function, okay? So, on this next one, it says given g of x, and then it wants you to plug in all of these different values. So I want you guys to try this one on your own and then just check your answer with the key to make sure you're doing it okay. On to number 3. So number 3 says given the graph, evaluate the function at all the given values. So this first one says f of 0. So it wants to know what is the y value when our x is 0. So what I do is I find x on my or 0 on my x-axis, and then I just go up or down until I run into the graph. And if we go up, it looks like the graph runs into f of 0, or x equals 0, right at the value 5. So then we would say 5. Okay, f of -2, right? So we go -2. Follow that up. It hits here, it's a closed circle. If we went up any higher, it's an open circle. So I only care about the closed circle because that's the one that's included. So then f of -2 is going to be +6. Okay. From here, we're going 4, so +4. Follow 4 up. Hits the graph right at 5. And then f of 2. So then move to 2. Follow the graph up. Gives us 1. And then this next one here, guys, is saying, well, if y is equal to 5, what x values do I get out? So in order to do this one, I would go to 5 on my y-axis, and then I would follow around to all the points that it hits. Well, the first one is right there. We get 0. The next one, if we follow the graph to the right, we would hit 4. So 4 is a possible x value. As you can see, if we would go left, we're never going to hit the graph, so we're good there. The last one says, well, what about f of x what is our x value when f of x is equal to 9? So again, same idea. We're going to scroll up to 9 here. And then if we go left, as you can see, the only spot I would hit the graph is right here at this open circle. Open circles are not included, so we would not put that as one of our answers. So then we come to the right here. We go to the right, we go to the right, we go to the right. It looks like it's going to hit this line. So what we need to do is complete the line. So the slope is up 2 to the right 1. So we go up 2 to the right 1. And if you follow that up correctly, you should see that we will go through that point. So that's going to be an x value of 6. Okay? So that's how you would do a question like that. All right, let's keep going. So, graphing piecewise functions. How would we do this? Not the easiest thing to do, not going to lie, but I think you guys can figure it out as long as you just make sure you're practicing this after the notes. So, this is saying if x is less than 3, we're going to use this line. And if x is greater than or equal to 3, we're going to use the second line. So then, what we do to start these questions is we plug in the boundary points, okay, or the boundary x values. Those tell us where things are going to change. So I'm going to plug 3 into both equations. So if I plug 3 into this top equation, I get -3, okay? And then if I plug in 3 to the bottom equation, I get 2/3 times 3 minus 4, which gives us 2 minus 4, which gives us -2. So this actually gives us points. This first one would be 3, -3, because we plugged in 3. This next one is going to be 3, -2, because, again, we plugged in 3. In both of these cases, we're going to graph each point. I'll graph this orange one first. So it says if x is greater than or equal to 3, we get this point right here. So we go 3, 1, 2, 3, -2. Because it's greater than or equal to, we go closed circle. On the other hand, we have 3, -3 if x is less than 3. And because it's just less than, so we go 3 to the right, down 3, 1, 2, 3. We're going to go open circle right there. Okay, so those should be the 2 points that we have plotted so far. After we plot these boundary points, it's really just making sure we correctly follow the slope. So the slope of this top equation is -1, okay? The other thing we need to know is the direction of travel. This is saying for all x's less than 3. So my x's that are less than 3 are going to the left here. So then we need a slope of -1 going to the left. So in order to get that slope, it's going to be rise 1, run 1. We need to go -1 to the left, and then we're going to rise 1. Okay? And then 2 points is enough, but if you want more, -1 to the left, rise 1. And then because this can only go to the left for when x is less than 3, we're going to go up and to the left with our graph. On the other hand, we have a slope of 2/3, so up 2 over 3, and that's when x is greater than or equal to 3. So that means all my values to the right. So then the graph here is going to go up 2, to the right 3, 1, 2, 3. And then again, we just connect those 2 points. Okay? And then bam, that's our first piecewise function. We have 2 different lines drawn. So on our graph, we should have 2 different lines drawn. And then we should also have this boundary point is where it's changing. Okay? So then this value of 3 right here is where everything changes. All right, continuing on. Domain. Domain of this function, as you can see, goes to the left forever, goes to the right forever. The only thing we're worried about is this middle section right here. There's a little jump, but that 3 value is still accounted for in our x's. So our domain, all real numbers. Okay. Range. So if we're looking at range, we need to see lowest y value. So the lowest y value is right here, but it's not included, so we're going to parentheses it. So parentheses, -3. And then how high is it going? Well, if we follow this graph up, it's going up to forever. So we would say -3 to infinity. Okay? And then that's the domain and range. All right? Next one. So, next one has the same idea. We need to plug in our x at the boundary points. So 0 is our boundary point here. So we're going to plug 0 into each of these things. So -1/2 times 0 plus 1. In the next case, we're going to have just the number 4, because when x is equal to 0, we get out 4, so 4. And then the last one, x is greater than 0. We just plug in 0 here. So then the 3 points that we have are 0, 1, once we finish that one. This point is 0, 4. And then the last point that we have is 0, 0. So now we need to go through and make sure, is it open circle or closed circle? So at 0, 0, that's this value right here, no equal to sign, so we'd be open circle. 0, 4, that's our equal to sign, so then that's going to be our point, so 1, 2, 3, 4. And then the last one, when x is less than 0, right, so that's going to be an open circle because it's not equal to, so 0, 1, it's going to be an open circle, okay? So those should be the 3 points that we have at 0. So then let's graph away from there. So our blue or our teal line here is going to have a slope of -1/2. This is for all x's that are less than 0, so that means we need to go left with the teal line. So then we need to follow the slope so it goes left. It's rise 1, run 2, so we need to go -2, up 1, -2, up 1. So then we follow this up like that, and that should be the direction that one goes. This next one, the only thing that it has is a point when x equals 0, which we already have that one, so we don't need to do anything with the middle. And then the last one is for all x is greater than 0, so then this is to the right here, and then that's going to have a slope of 1, so right 1, up 1, right 1, up 1, and then we draw this graph. Should follow that line straight up, okay? So in this case, we have 3 different parts. We have part going left, we have a singular point, and then we have a part going right. Talking about the domain of this function, again, we're going left and right forever, all real numbers. The only thing we have to be careful about is this middle section right here, and that 4 value is accounting for that middle section for when x is 0, so it is all real numbers. The next thing we're looking at is the domain, or the range, sorry. So the lowest value that we get is 0. It's an open circle though, so we use a parenthesis, so 0. And then if we would follow this line up, it's going to go up into infinity, so 0, infinity. Okay, so that would be the range. All right, so let's do one more. Graphing one anyway. Number 6. Number 6, again, we plug in all of the boundary points. So this first one is at -2. So we're going to plug -2 into this equation. So -3/2 times -2 minus 1. Let's just solve this through and get this point. So 2's cancel. -3 times -1 is +3 minus 1. So that gives us 2. So then the point that we have is -2, 2. Okay, let's take a look at the next one. This next one has 2 boundary points. So there's a boundary point at -2 and a boundary point at +1. We have to plug in both of those when we're doing this one. So we're going to go -2 plus 1. That would give us -1. So then that left boundary point is going to be -2, -1. And then it's also going to have a right boundary point when we plug in 1. So it's going to be 1 plus 1. That gives us 2. So then 1, 2 is that right boundary point of that middle line. And then if we continue on, the last point that we're looking at is for when x is greater than 1. We get the value 3, right? So then that's just 3. So then our point here is 1, 3. Now we can plot all those things. So we go right 1, up 3, 1, 2, 3, open circle. Okay. And then we're going to go to the right 1, up 2. So right 1, up 2. That's a closed circle because of that equal to sign. Then we're going to go -2, -1. Also a closed circle because of the equal sign. And then the last one is an open circle because it's just less than -2 and then +2. So open circle right there. So how do we draw this, right? Well, first of all, we have to just draw each section So the slope here is negative 3 halves. So that's going to tell us what's happening when x is less than negative 2. So going to the left here. When it's less, we're going negative 3 halves. So that's 2 to the left and up 3. And then we can plot that. All right. The next part of this graph, because it already has 2 points, right? We've already plotted 2 points of this middle line. We can just connect the dots, and that'll give us the middle section. And then the last part of this graph is saying, well, when x is bigger than 1, so as x goes to the right here, the value is just 3. So that's going to be our horizontal line, y equals 3, continuing off to the right. Okay. Now we have to take a look at some stuff here. So, domain. Are all of our x values covered? So this is a point of concern, but it's covered here. This is a point of concern, but it gets covered here. And then after that, it's going to the left and right forever. Okay? So, our domain is going to be all real numbers here. And then our range is talking about all of the possible y values. So the lowest one that we get is that negative 1. This time it's a bracket because it's included. And then how high is it going? Okay, well, it's going up forever until we get to this spot right here. Okay, we need to make sure that this section that's missing is covered somewhere else. So we look across the graph. It is, right? From here to here on our graph, so this section right here covers this missing section. So we're still good. We're still going up. And then it looks like we also are just going to continue going up forever because of this. Okay? So we go from negative 1 all the way up to positive infinity because it's going up forever. Okay? Range can get a little tricky on these questions. So if you have a question on that, what we just did, feel free to ask me. All right. So those are the first 2 pages. Now we're going to head down to the 3rd page. All right, guys, last page of these notes. Just wanted to take a little break right there to make sure everything was recording correctly because that was a lot of recording. So, last page. Now we're going to actually write a piecewise defined function given the graph, okay? So, the best place to start these is to start at the boundary points, right? The boundary point is where everything is changing. So here we can see that it's all changing at x. So we have something where x is less than 1. I know that because open circle, and then it's going to the left. So that's my x less than 1. As you can see, there's a singular point here. Whenever that happens, that tells us that x is equal to 1. There's going to be a value. And then the last section here is going to the right after that. So then those are my x is greater than 1. So those are the 3 boundaries that we would look at here. After that, it's all about just writing the linear equation that goes with it. The point here is probably the easiest, right? So the point in the middle, that's going to be negative 1. So when y is negative 1, x is going to be 1. Continuing on, we have this graph over here going to the left, right? So when my x is less than 1. We have the y-intercept, which is nice. It's positive 2, so that's plus 2 on the end. And then we just need to find the slope. Well, the slope is up 2, to the left 1, so that's negative 1, up 2. So then that's 2 over negative 1, x. So we can just erase that and say, well, negative 2 is the slope. And then the last thing that we have going on is this equation to the right, okay? We have a slope, so to the right 1, up 1 would tell us that the slope is 1, so we could say 1x. Now it's about finding the y-intercept. In this case, what we're going to have to do is we're going to have to follow the graph. So we go down 1 to the left 1. This graph would go down through this point right here. That point's negative 1, 2, 3. So then we would say minus 3 to find that last point. Okay? Domain here. The domain in this case is going to be all real numbers because it's going to the left and right forever, and that x equals 1 in the middle. That's the only nervous spot for the domain, and it is included at one of those points. After that, we need to talk range. So we have the lowest value right here, and as you can see, it's going up forever and ever, so we don't even need to worry about any of those jumps. So then our lowest point is -2, parenthesis, because it's not included, and it's going up to positive infinity. Okay? All right, next one. So next one is actually only two functions, right? This is an absolute value function that's just cut off, and then our other one is just a linear function. So there's two functions going on here. I'll make it orange. So the spot of no return, right, or our boundary point is right here at x equals 1. So we have in a case where x is less than or equal to 1, -1. And then we have a case where x is greater than -1, right, because this is -1 right here. We have greater than -1, less than or equal to -1. So then from here, we need to write these equations, okay? Linear equations probably a little bit easier to us, so we will start there. We have a y-intercept of +4, so +4. And then we just follow the slope. Slope is up 1 to the right 1. So then we have 1x, or you could just put x. You don't need to put 1x. Absolute value. This one's a little bit harder. Remember our absolute value, though? We have the transformation function is x minus h plus k. And then the slope is the a value. So the slope of our line is a. And then remember, h and k actually come from the vertex. So if we look at this vertex of this absolute value graph, it'll tell us what h and k are. So the vertex point right here is -3, -2. So then our h is -3, our k is -2. So then let's fill that in. We have the absolute value of x plus 3 minus 2. This is +3 because negative, right? Then lastly, we just need to decide the a value. What is the slope of this thing? So it's opening up. That means the slope is going to be positive. And then also it's going up 1 to the right 1. So then the slope is just 1. Okay? So you can put 1, you could put nothing, you could just have it like that, and you'd be good either way. Okay? So that is how we write the equation for an absolute value graph. Domain in this case, we are going to the left and right forever. There is a value included at the jump, so domain is all real numbers. And then we need to talk range, right? Well, the lowest point is that -2, so -2 is at the bottom here. And then as you can see, this graph is going to go up, but then we have a jump right here. But that jump, right, this jump right here is accounted for if we go to the left, right? So all of this part of the graph is accounting for the jump that happens right here. So then we can say -2 to positive infinity, because if we would just follow this one up, it would be going into positive infinity. So the only things that we need to be weary about when talking domain is the boundary point. Is the boundary point included somewhere? That would be the only thing that interrupts a domain. And then the only thing that interrupts a range are also jumps like this, right? We could have a jump that goes from here to here, and then if this was going down forever, this was going up forever, we'd have to write a little something different, okay? So let's take a look at this last one. All right. So our last one here, we have 3 cases. So one case here, one case here, and one case here. So we have, it looks like x is less than -1. It's going to be this first case, right? This next case is actually an and inequality because there's 2 endpoints. We know whenever there's 2 endpoints, it's always going to be a section of the graph. So it starts at -1. Whoops, I just noticed something. This is a closed circle, so we have to say x is less than or equal to. In our next one, we have an open circle, though. So open circle says x is greater than 1. Okay? Actually, let's write it this way. It's always going to be an x in the middle. It's greater than 1. Okay? Greater than -1, sorry. And then it's less than this 2 right here. So x is less than positive 2. So that's our and interval there. And then the last section here, the last section of this is when our x is greater than or equal to 2. So those are the 3 separate parts of this graph. Now we have to just write the equations for each one. So following the slope, this is 1, 2, 3, to the left 1. So that's a rise 3, to the left negative 1. So negative 3 over 1, x. And then if we followed that down, 1, 2, 3, to the right 1, it would give us the y-intercept. So the y-intercept is negative 1. For our next equation, right, the yellow or the orange color, however you see that, goes through positive 2. So positive 2 is the y-intercept, the slope, up 1, right 1. So the slope is just positive 1. So we would say x. And then the last one here, the last one has a slope of positive 2 to the right 1. So 2 over 1x. If we followed it down, so down 2, left 1, down 2, left 1, right, this graph would go through the point negative 7. So negative 7 here. Remember, you don't need to write the 1 if you don't want to. You could just have 2 times x minus 7. You could have negative 3x minus 1 for the top. Okay, that works. Or you can put the 1. I'm not going to count it wrong if that's how you see it. So domain in this case, we jump here, but it's included here. We jump here, but it's included there. So domain is all real numbers. The range, if we go to the lowest value, right, the lowest value on this graph is right here. So that's negative 3, and it's included. And then this graph just goes up forever and ever. So it's going to be negative 3 to infinity. Okay. So that is the start of piecewise functions, guys. I know they can be difficult. So please, please, please come with questions if you have them. All right. I hope you guys have a great rest of your day.